can use it for predictions and for inferences for the future, immigration analysis. For instance, there's an example here. If the average age of completing your undergraduate degree in Kampala is 22, or even in Mukono is 22, let's think of the metropolitan cities of the country, okay? You can use this age that you have of just that sample size of Kampala and Mukono universities to make an inference for what the age of graduation would be for the rest of the country, and see how much confidence you have within that result. Is it what, 95% confidence, which is what we usually target, 95% or higher? Or is it less? Then we know that not necessarily the rest of the country do they graduate at age 22. So, how we do the sampling? Like I was mentioning, the random sampling or simple random sampling. You're just going randomly picking individuals or picking samples, or maybe it's a biological experiment, you're picking particular plants or particular animals, okay? Each one of them has the same probability of being picked. If your total sample size that you want is 1,000, okay? From a population of, you speculate the population is maybe 50 million, but you're only sampling 1,000. The probability of getting or sampling each individual would be 1 out of 1,000. Okay? So it's equal chance for every one of them. Now it has some positives to it, okay? In that it's simple to implement, okay? Going randomly and asking individuals for an opinion or sampling them for whatever it is easier and cheaper. Hence, you will find it be used a lot when you are running survey studies. Okay? When you're surveying people on opinions, when you're surveying people on any other thing it may be, you're mostly going to be using a simple random sampling technique. The downside of it, it has bias to it. Okay? The bias being that in your randomly sampling, if, for instance, your question is too specific or too contextualized, for instance, I am interested in looking at persons with disabilities at the university, okay? That's who I'm interested in getting opinions about, maybe the inclusivity of the university, okay? But then I randomly sample everybody else, okay? And a probability that they all have the same chance of being chosen. But let's say my population size or my sample size of people living with disabilities is much, much smaller than those that do not live with disabilities. I am automatically biasing the results, okay? So, this kind of technique does not apply to specific questions that have a context to them. If you're interested in particular groups, if you're interested in a particular context, you cannot use this type of sampling as you have already biased your results. Another approach of sampling is stratified random sampling. Okay? So it's still random, but now you have groups. You add the context of groups or strata. Okay? I could, for instance, decide, as I'm randomly sampling, okay, I want to look at gender. I want to look at people with disabilities and separate that result from those who are not living with disabilities. Okay? Male versus females. Okay? I'm still doing it randomly, but I have groupings. And in these groupings, I'm ensuring to have the same sample size. All right? That way I'm able to capture the context of what is going on within that population. Okay? So here you have more precision or more robustness, but the downside is you have to have some prior knowledge about that population. Of course, when I keep giving the example of the university, it's likely you do have some knowledge or you have access to some knowledge because you can either go to the registrar and get this information at the department level, you get some information. Let's now stretch this out to being a problem that's around a district or around an entire country. You don't have prior knowledge on some of these groupings, okay? So meaning you must do a baseline study or get some information before you can use this type of technique, okay? An example here, if you are targeting again that very question, okay? And you're interested in who gets to finish university at which age, here you're looking at persons between ages of 18 and 22, but you're separating your strata, males and females. Or I could even decide to separate my strata based on economic backgrounds. That tends to be a lot of a study most of the times, okay? To try and see if it is feasible for both groups of people with different economic backgrounds to graduate at the same time. Okay, a different technique is clustering. Okay. So clustering you would use if you're working with many districts now, many parishes within a district. Okay? You're working with populations that are spatially stratified or spatially referring to in terms of distance. Okay? They are spaced or they are grouped by distance or separated by distance. Okay. So here what you do is you divide your samples into smaller groups, or what you would refer to as strata or clusters, and then you can decide what these clusters are based on. Okay? You can decide they are based on a district level, a parish level, a village level, okay? But it's not the kind of grouping as the previous that is maybe on the demographics of that population. This is based on the distance apart. So it's suited to the larger studies, okay? Like a census would be suited to this when they are now giving us the results for each district and its performance, okay? In District X, we have these many males and females. We have this much deaths at these age groups, okay? So now notice they have within there the strata. Yes, you have a question?
Is it possible to define something for the center, like strata inside the cluster?
Yes, exactly. So it is possible to use two techniques within one data set, but depending on how you pose your question. The example I'm giving, the census, okay? And now you have the clusters being the districts, okay? You're comparing those districts in terms of the numbers each has. Then you create these other stratas of groups, and they could be gender-based. They could be, they usually give information on mortality rates. Those are very key aspects. Birth rates, okay? So they could, for instance, decide the strata are going to look at underage births, okay? Versus of-age births. Those are different groupings, but still using two different types of sampling techniques. Each data set that you handle, you can have more than one hypothesis, okay? This is what you need to keep in mind. You can have more than one hypothesis because you're interested in possibly answering more than one question. Your hypotheses are based on the assumptions you're making, and you're going out there and you're testing these questions, okay? So depending on how you pose the question or the hypothesis will determine the type of sampling technique that you're going to use. Okay? Right. So it does also have a possibility for creating bias. For instance, I work on research projects to do with coffee and cocoa. And many of the times when we are researching coffee, we're looking at the major producers of the country and we use them to make inferences for the rest of the country. So we are looking at districts like Mityana, Masaka, Mukono is also one of those. We're looking at Mbale, you know. And that is where most of our research work would be, or our results would come from. Okay, and we then use them to make inferences for the rest of the country. However, what we now did notice is the inferences we're making do not, on ground, make any realistic sense. If we're talking about growing now the coffee and seeing what the challenges would be for, say, a farmer in Gulu, okay, versus a farmer in Mityana, they will be completely different. And yet we've been using that data to make inferences for the entire country. Okay? So it does have some aspects of bias in that way. Okay? One has to be careful. And also, in statistics, when you do your sampling and you realize it does have a bias to it, you are supposed to state where you see the possible bias coming from. Okay, we'll see when we make the calculation for how much sampling size do we need. Okay. In some realistic situations, real life situations, you don't always get the sampling size that the equation has given you. Okay, you calculate your population, maybe you make an estimation that there are 8 million farmers growing coffee in Uganda. And you want to take a sample size that you can investigate in each district. Okay? So let's say, for instance, it tells you you must sample 200,000. You may not have enough funds to sample 200,000. You may not have the sort of reach where your community will be willing, or 200,000 people will be willing to speak to you on whatever it is you're investigating. So, in statistics, we always state where the biases come from prior to doing any of the analysis, prior to even doing your descriptive statistics or any predictive statistics. You state it. My bias has come from the sampling. Maybe I couldn't reach this, but how do you correct for it? Okay, we'll also get to see that aspect. How do you get to correct for that bias? Okay, so another sampling technique is to be systematic. So here you are selecting the samples at intervals that you have determined. They could be time intervals, they could be series intervals. I'm going to only sample the 11th student that I run into in my compound, the 9th student that I run into. But you must do it consistently, that is the interval you're using. Or I'm going to sample every 1 hour. If you notice in a lot of lab experiments, there is a lot of systematic sampling, okay? Perhaps they could give, if it's an experiment to do with a vaccine being tested, and then you have any mice or rabbits that have been vaccinated, and maybe there is also the control sample that has been shot up with a placebo. Usually that is maybe sugar water. And that is then tested to see their reaction, okay? So they could decide, let's test these rabbits every 2 hours to see their response to the vaccine and also see the response to the placebo, okay? And that way, they get the results of what could happen under a particular drug or vaccine. The study is suited to those kinds of situations that you can control, okay? Like lab experiments. But if you now place it in a realistic, maybe customers walking in or students walking past the grounds, you may find that you may not get to, say, the 9th student on that day. Maybe only 5 students passed by that day, alright? So you may not be able to carry out a systematic sampling, whereas it's more suited to experiments that you have control over, okay? Now the bias can come in if you change the order of your sampling. If you decide I'm going to collect the results from the rabbits every hour, and then the next time, you're too rushed and you're like, oh no, I'll collect it every half an hour, okay? Those changes in how you have collected your results will bias the eventual data analysis. So there is also convenience sampling, okay? So this is almost like the random sampling, but it doesn't have as much rules as the random sampling has, okay? Because it's just at convenience. You don't have to hit a specific sample number, okay? And all you're interested in is whether the samples are available, whether the people are available to give you those opinions, those perceptions, and so on. Okay? So you could be seeking a perception about a product or feedback. Is it good? Is it bad? It's quite simple and it's the cheapest, but it's highly prone to bias. Now, a lot of students tend to use this as their form of sampling, if you'll notice. A lot of your monkey surveys that most students would run would be based on this kind of approach. But it's highly, highly prone to bias, and a student must ensure to point that out and have to correct for it when doing the analysis. So, how do we choose the right method? This is based on, firstly, the population size that you have and how it's distributed. Okay? For the larger populations, you should use the cluster or systematic sampling. Okay? But if you have the smaller, then you can use the convenience sampling or your random sampling. Also depends on how much money you have or how much manpower you have. All right? The tool that you're using in doing this sampling can also determine how quickly you can do it. So it's also part of the resources that are being referred to here. Then the level of precision that you want to have. Of course, it is ideal to want to have the highest confidence within your sampling technique, okay? So it's important to be careful with what you use. A lot of the time, the stratified is the most robust, so having those strata or those groupings. But also a lot of the time we use strata because most of our hypothetical questions are based on groupings. We don't assume that life or populations are based on just the opinion of maybe you as a female, just like that. But even within that grouping of gender as female, there will be different groupings that have different opinions. Whether it's a teenage kid, whether it's a youthful person, whether it's an age-old person like myself, the opinions would vary. Okay? Then the diversity of the population will also help you determine what technique that you are using. Again, here stratified can be really good at capturing all these diverse groupings. Okay, so how we determine the sample size that is suited to the question at hand. Sample size is very, very important. We'll see it being mentioned from now up until, some of you may do this until your PhD. Sample size will be a part of that, okay? Whether you're in research, whether you're going to be in the work environment, a sample size is a very key aspect. When Parliament is discussing a bill on the floor, for instance, if I can give a scenario that we thought may not involve sample size or may not involve statistics. When we are discussing a bill on the floor, they're expected to go speak to their constituents, the people that voted them in. Okay? They're expected to go explain that bill and the clauses and contents within it to the people that voted for them. And they're expected to sample the opinions of those people. Okay? So every time you see your MP go on the floor and discuss a bill, and they don't discuss it with statistics, you know for certain they do not approach the constituents. Okay? And this is how, I know maybe sometimes you watch your parents watching these TV shows and you're like, why do they enjoy this so much? It's because they're looking for that attention. Okay? They want to see how engaged their MP is with the community regarding these important issues. But Parliament also employs statisticians that work with these MPs. So these MPs don't just go there to collect this information themselves, they go with experts, okay, that are supposed to give them the actual numbers. So sample size is a very important aspect for the MP to now come on the floor and say, this percentage of my grouping had this much good to say about the bill. This is why we are pushing for it as our region. Okay? So sample size is very, very important. So, how the key aspects here in determining the sample size. Okay. One of which is the confidence interval or error of margin. Okay, as I mentioned, all stats will have some bit of error. You have to determine how much error there is. You have to determine how much confidence you have within your result. Okay. So, the confidence interval will look at the degree of uncertainty or certainty in a sampling method. Okay. For instance, if you survey 1,000 people, and the confidence interval. So these numbers tend to be reported as a value and a percentage, okay? For instance, here you get a confidence interval that is 6 and 60%, okay? Showing you that the sample respondents have a positive review, for instance, about a product. These are the values you get. Confidence interval of 6, and that 60% of the people are saying, yay, we like this particular product. What this confidence interval implies is that you can be confident, okay, that 60 minus 6 of that margin of error, which would be now 54% of the people like the product, all the way to 60 plus 6, or 66% of the people. Yes, please do come in. Part of this class? Okay, sit down, please. So 66% do like these products, okay? So you're asking, how then would this be reported if the society that you're speaking to is not conversant with things such as confidence in? How would you report it to a day-to-day society? Okay? So when you do report it, you're of course going to be reporting the 60% that you got as the result. Okay? But when you are reporting to academia, academia wants to know how confident are you in that result. Okay? You then point out your confidence interval and you can explain what that implies for people's perceptions of that product. Okay? There are societies that get interested though and want to know how much confidence you have. The last time the UBOS did the census, the newspapers were now reporting all of these statistics with some nice visuals, okay, just to get everybody involved. Because usually, as a society, we are mostly interested in what's that final estimation, okay, of population size. But now they were delving into other issues. They were pointing out to us, for instance, our BMIs, our health statistics versus city dwellers and rural dwellers, okay? So it's important that you also understand it so you're able to convey to every bit of society. Then we have the confidence level. Now this one will come as a percentage of a probability of certainty, okay? The percentage of the probability of certainty that that confidence interval that we had, the 6, is actually true, okay? So this one is expressed as a percentage, and it's usually the one we attach, even when we are communicating to all walks of society. It's the one we usually attach. We rarely attach the confidence intervals because those can sometimes be confusing, so we attach the confidence levels. So, within statistics, a test that has, or a result that has a confidence level ranging from 95% onwards is quite good. Okay, that is the target we are seeking. Okay? If we have a result that is less than 99%, we report it as well. You don't go and then fudge the numbers and change them just because it has a lower confidence level. You explain why it could be happening. And why your confidence level could be low. Some of the things pushing for that are sampling technique, error in sampling technique, or error in the sampling number. Things of that nature can push the confidence level down. We will also learn about the other types of errors that can generate these confidence levels to go down. Type 1, type 2 errors that we'll learn about later. Okay? We'll also learn about, or have been learning about, if you use the wrong statistical test on the wrong variable. That will also lower your confidence. So already you can see where the errors are coming from. So if you have a 99% confidence level, this will imply, with this sample size that I have now used, I have 99% confidence that if I go from this sample to the bigger population, there will be certainty that still 60% of the people like the product. Okay? 60% of the total population. Because now the sample has said they like it at 60% and I have 99% confidence in that. Do you ever have 100% confidence level? I know that could be a question. Very rarely. It is possible, but it is very, very rare. It would have to be the perfect sense of sampling, perfect form of generated data, and so on. No errors whatsoever. At the most, we tend to find 99.99, percent confidence level. Okay. But I think also it's because statistics is structured to be Puritan, okay, very stringent, very strict, that it doesn't allow for any possible errors because a lot of the tests we use are based on some random assumptions. Okay? If you're sure about something, let's say you hypothesize something and it is a certainty, okay? Let's say you hypothesize that the DNA of the people in this room illustrates or comes back as species Homo sapiens. You're certain about that, okay? We are all Homo sapiens. You expect that to be a certainty, okay? But let's say you want to look into the historical backgrounds of each of us, okay? to then see if our DNA all stems from maybe East Africa or Uganda and so on. You're not 100%, you may feel you're certain because we are all nationals of our country, but you're looking at now a historical, maybe we have had some immigrations, some mixtures and so on. Okay, that will lessen. But a lot of the tests in statistics are made on the assumption that things are random. Okay, another technique we use, the descriptive statistic standard deviation. Okay? You know the one that you look at the distribution of the data from its mean. Okay? We can use this to calculate the sample size in the same way that we've been using it to calculate the probabilities. Okay? And for instance, if you have a standard deviation that's high, okay, you know that your data is more variable. Okay? It's more distance away from the mean. Okay? So that is a greater deviation. If you have a variation of responses within your standard deviation that is quite wide, okay, then that tells you that population is diverse. Okay? Already you can see that's a diverse population, or that's a diverse sample that you're working with in terms of their opinions or in terms of some of the information you may have received about them, if it's height or weight and so on. And we will be using that to calculate the sample size. Okay? So, how we calculate the sample size? We want to first determine the population size. In some scenarios, the population size is already given to you. In other situations, you do not have it. A lot of when you do your research work, you do not have the population size. Right? Then we'll determine the confidence interval, the levels of confidence as well, the standard deviation. In situations where we don't have or don't know the population size, we use a standard deviation of 0.5. Okay, so that would be a statistical rule that we can work with. And then we also convert the confidence levels into z-scores. Okay? In Excel, you are seeing how to calculate your z-scores, but there is a standard table you can get off the internet that shows you how to convert the confidence levels into z-scores. Okay. So one of the more commonly used formulae for calculating population size is Andrew Fisher's. Andrew Fisher was around from the 19th century, quite age-old time, so it's been around forever. And it works with the z-score table. So this formula will find you the population size, okay? Or the sample size rather, that you must work with at a confidence level of 95%. So now you already know, as I am starting with this Andrew Fisher's formula, the sample size that I have is at a 95% confidence level. It's not at 100% certain that this is the sample size I must use, but it's a 95% certainty that that's what you must use. Okay? So, this formula has the z-score squared. It also has the standard deviation, which are illustrated with a P, and then it also has the error margin. Of course, you can see here the table, which you can find on the internet, has the confidence levels and the z-score. So if you know the confidence level is at 95%, the z-score corresponding is 1.96. Okay. But if you do know the population size, and you're wondering which scenarios might I know the population sizes. You do know the population size of, for instance, 2025's student number that you can access, okay? You can know the population size when you start working of a company's employees, okay? That would be a known population size. But you're only working with a sample over here. So for instance, if you need just a sample of 500 people from that entire population or company that you know, this would be the formula that you would use, okay? So again, it has the z-scores and the margin of error and the standard deviation. So this margin of error may vary, okay? This margin of error may vary based on the non-population size that you have. Okay, so I also have you pegged down for a reading and presentation exercise. So please take this down because I don't know, the Moodle may be up and going perhaps this afternoon. So you now know some of the error points where they can come from. I just need the types of errors over here, type 1 and type 2 errors, and how they apply in hypothesis testing, and how they apply when you are working with a data set. So in this particular assignment, you will not just make your PowerPoint slides, okay? You can also make a practical illustration with a data set. Okay. This will be awarded marks. And how you can mitigate for these errors, okay? And since I was giving the other types of errors, what can you do with these ones, right? So you find your assigned groups up the Moodle. Today's. So you're going to make six groups, okay? 6 groups. Yeah. Oh, a bit too big. Okay, no. I'd rather you're 6 people in a group. So some people may get a little lazy to do.
Awareness group.
Okay? So 6 people in a group. Sorry guys, 16. Wednesdays, 15th is Wednesday. Let's change that.